welcome to the International Code Council Region 1 and Region 1 Radio Show. My name is Tim Spears. I'm the host of Region 1 Radio. Region 1 was established in 2014 and we're made up of 3 states, California, Nevada, and Hawaii. That also includes many ICC chapters. We are dedicated to excellence in education and engagement to promote a safer environment by bringing individuals together. Our podcast aims to provide valuable information and insights to professionals in the building and fire safety industry. We cover a wide range of topics, such as industry updates, best practices, and we interview experts in the field. We also aim to engage our listeners by discussing many relevant topics. Whether you're a code official, a building inspector, architect, engineer, or someone that's interested in the building and fire safety industry, our podcast is for you. We believe by bringing individuals together to share knowledge and resources, we promote a building safety environment and contribute to the betterment of our communities. So if you want to stay informed and up to date on the latest developments in the building safety industry, be sure to tune in to ICC Region 1 Radio. Today we're joined by Dr. Aghayere from Drexel University, a renowned figure in the realm of structural engineering, with significant contributions to understanding structural failures, notably the tragic Surfside Condo Collapse. Dr. Aghayere has been a sought-after voice in media outlets. In this conversation, we'll journey through his academic and professional path, explore his passion for structural engineering, and understand the critical role of structural failure analysis from both a code official and an engineer's perspective. Stay tuned for an enlightening discussion that bridges the gap between theory and real-world applications. All right, Professor Dr. Aghayere, hopefully I'm pronouncing that correct.
Yeah, you're very close.
I've been practicing like for the last 3 days to try to figure, make sure I get it right each time.
Yes.
But you're with Drexel University, have done a lot of work in regards to structural failures, and you did a lot of work with the Surfside Condo Collapse. I'm sure a lot of people that are listening to this podcast are going to be able to identify you and some of the different periodicals and videos that you've been, and even like I last night I was watching the Smithsonian episode that talked about the Surfside Condo Collapse and the different, the 10 different steps or 10 different things that went in to potentially cause that failure. So, but welcome to ICC Region 1 Radio.
My pleasure to be here.
Yeah. Well, like I said, I definitely want to talk about structural failure analysis and maybe more at a code official level and less at a structural engineer level. I'm sure that there are some structural engineers that listen, but for myself, I'm a fire code official. So the idea of structure is more of like, how do we make sure to secure the structure for us to go in and do what we need to do later, like either fight a fire, do a fire investigation and those types of things. But we also are in buildings pretty frequently and see a lot of different failures, at least as it relates back to that. So welcome. Can you share a little bit about your background? What really led you into, structural engineering and really the kind of the specialty of structural failure analysis?
So I went into civil engineering because I had uncles that were civil engineers who seemed to be doing very well. So I mean, like many students, I didn't, I kind of had an idea what civil engineers did. I knew that, they did, they worked on structures, roads, and civil infrastructure, but I really didn't know specifically what exactly they did. But I knew my uncles were doing well.
Okay.
So I decided to go in civil engineering. I got my bachelor's degree in civil engineering from the University of Lagos. And then proceeded to MIT and got my master's degree in civil engineering, but with a focus in structures.
Okay.
And then from there, I went to the University of Alberta in Edmonton to get my PhD.
Okay.
Then after getting my PhD, I was really, green as grass, no experience. And so my advisor, who I went to work with in Alberta, he was a very famous guy. He was the president, once the president of the American Concrete Institute.
Okay.
Jim McGregor, he's late now. And he advised me that I should go work in the industry. it would be good for me to get some experience. So I
Right.
went got some experience in a consulting structural engineering firm in Toronto, and worked there for about 8 years. And then from there, I proceeded to academia at the
Hmm.
Rochester Institute of Technology, became a professor there. And then after 13 years there, I moved to Drexel University as a professor as well. And so I've been here since then, since 2009.
Okay.
And why structural design of structures?
Yeah.
Because, I just, you can see the structures that you design.
Hmm.
You can take your friends and family to see those structures, and you can see them for yourself.
Yep.
Bridges, uh, high rises. And by the way, I mean, what skyline is there without structural engineers?
That's true.
And so to me, um, I felt that structural engineers, I'm sure other engineers contribute to the, building the fabric of society
Right.
and building civilization. But I see that structural engineers are real at the forefront of building that fabric of society. Places where people have fun,
Yep.
places where people learn.
Yep.
I mean, any building. And so that's what got me interested. I wanted to go into structures, and it was also more mathematical.
Oh,
It had
yeah.
math, physics, and so I was excited about doing structures, exercises. So that's how I got into structures. As far as structural failure analysis goes,
Hmm.
um, back in the early 90s when I was designing working on a project in Toronto, I was designing a walkway, a very long walkway. It was a
Okay.
science, they called it a scientist walkway. It was where the scientists will go on that long walk and to sort of
Like,
generate ideas.
yeah, creativity, like, right?
Yeah, but the whole thing was was hanging from the structure above. And
Okay.
so I had to design the hangars and all of that. My boss comes to me and says, "Hey, um, there was a collapse in 1981, in Kansas City, Missouri.
Yep.
The Hyatt Agency, and what you're designing right now is kind of really similar to that structure. Nothing wrong with that structure as it is, a
Okay.
concept."
Yep.
But the details, I mean, there was something wrong with the details. That's why it collapsed. I want you to review that collapse. I want you to reflect on the lessons learned from that collapse and
Uh-huh.
apply it to the structure that you're designing.
Okay.
So I researched the collapse. 114 people died. Uh, more than 200 people injured. But then I asked myself, I looked at what caused the collapse. It was
Right.
so simple. I
So what
mean,
was it? What
it,
was the kind of the thing that precipitated the collapse?
So what happened was that the hanger rod was supposed to be just one hanger rod going all the way from the second floor all the way up to the roof,
Okay.
and one hanger rod, but it was supposed to be threaded. And the architect, I think, or the contractor at the last minute felt that building that would be very difficult because I mean, it was buildable because you have to have the nuts go all the way, to each floor level that's being supported.
Right.
But then you are going to have this ugly threaded rod
Yep.
all the way up.
Yep.
And so the contractor called the engineer and said, "Can we change it into double rod? So we're going to, instead of having one rod going all the way, we're going to change it into double rods. This rod will hang, carry the floor from below and hang it from this level. And then from here, we will carry both, carry
Right.
it." Problem was that nobody took a look at the change in loads.
Yeah.
The load doubles in the connection of this upper rod all of a sudden because the floor from below is coming onto the floor here,
Yep.
and then this is picking up the floor from below and the floor at this level picking it up at the same time. So this hanger connection had two times the load.
That
Uh,
wasn't designed to hold
it
anyway.
wasn't designed for.
Yeah.
There were other things that were wrong. Even the detail itself, there was something wrong with it. But it was something that was easy to catch.
Yeah.
Um, apparently nobody either reviewed it, they didn't catch it. And, 114 people died. So that had an impact on me because I said to myself, um, not only does studying structural failures,
Hmm.
help you, find out
Yeah.
what happens in other failures, but it makes you learn lessons that you can apply to your own new designs.
Yeah.
And so, that's how I got interested in it. I got intrigued by it, and I said, I want to, see other failures. What are some of the lessons that have been learned over the years? And I found out that there was, many other failures
Right.
that happened over the years.
Well, and it's like one of those things, if you don't study the history, then you're doomed to repeat it, right?
That's
Um, and it happens more and more frequently. And I know, like, from like code provisions and things like that, a lot of the things that we have in the code nowadays are brought on by different, we've had different large scale fires or different collapses and things like that,
yeah,
that definitely make us take a, much bigger look at things.
that's correct. Yes. Yeah.
So,
So that's how I got myself interested in it. And also, when I started, when I got to Rochester, I was able to connect with an AE firm, a national AE firm.
okay.
So I was consulting with them for about 10 years, so I worked in Rochester for about 8 full time, and
Hmm.
then I'm teaching, full time and doing all the other things that we do as professors. And then I was able to consult with this firm to do their quality assurance, so I
Yeah.
would review designs. And so I was doing that as well. And
Hmm.
then in 2006, 2007, I was approached by an investigative reporter uh, in Buffalo, New York, to look at some bridges that were falling apart. They were really falling apart, and they had traffic
Yeah.
going on them, and so we were able to investigate that, analyze them, and brought attention to the conditions of those bridges to the Erie County Legislature, and so something was done about them. So, that's how I got myself really interested in that area of structural failure analysis. Now, we try to prevent and minimize structural failures.
Right.
Uh, as people that have come before me have said, it's impossible because human error is really what causes, structural failures.
Right.
I mean, tough God is really rare where you just say something
Yeah.
just happened out of nowhere.
Yeah.
Uh,
Out of the blue, right?
the
Yeah.
blue, yeah. So we try to minimize it. So that's been my goal, even with my students, to make sure that they leave the program with that awareness
Hmm.
of what causes structural failures and how can we prevent it in their own designs, or at least minimize it
Right.
in their own designs. And so a few years ago, I developed a course at Drexel here called Forensic Structural Engineering. So
Okay.
there's that. So I use the techniques that I teach in that course. I've used that. I tell my students that I used that when Surfside came along,
Yeah.
in trying to figure out what happened.
That's impressive. Well, and to be able to identify that as a need, right? To be able to then to identify, if you study the forensics of a collapse, hopefully we won't have it happen again in the future. And you shared a lot of key kind of experiences that were kind of turning points in your career,
Yeah.
from the Kansas City design to some of those other designs. But what other kind of key experiences throughout your course of your career really have kind of helped shape your kind of where you're at right now and the idea behind forensics and structural analysis?
Yeah, I mean, I think that the experience I got when I worked for that, full time for that 8 years, and also the working with the quality, the AE firm, really made me really interested in that area of preventing, how to prevent
Hmm.
collapses and
Hmm.
also how to analyze them.
Hmm.
Um, I once worked on a project, reviewed a project where they had a problem with the concrete pour because
Oh.
as they were pouring the concrete, it was a composite construction, meaning you have concrete on steel with
Hmm.
studs. And as they were pouring the concrete, the structure kept deflecting, kept deflecting, kept deflecting. And so the concrete supply ran out of concrete. And so the question was, why did they run out of concrete?
Yeah.
Well, because of a mistake that the designer had made in the software. The software called for, the software had a default. The default was that the beams would be shored during the concrete pour because
Okay.
the concrete and the beams don't act together in unison compositely until the concrete hardens. So
Okay.
the software had that default that you have to shore the beams.
Mm-hmm.
But during construction, the beams were not shored. And so that's why it kept deflecting, kept deflecting, kept deflecting. And, fortunately, it did not collapse because the
Yeah.
end result would have been a collapse. And people were working underneath. The contractors, employees
Yeah.
were working underneath. So thankfully, they figured that out. And so they were wondering what caused it. Well, it was because somebody failed to remove that default from the program, from the software, that these beams are not going to be short. Therefore, they would have had a bigger size beams rather than the smaller size beams that they
Mm-hmm.
had. And so that was a near miss. I study those too. I mean, I look at those too. So, we don't want collapses and we try to prevent collapses as much as possible. But this one was a very fortunate one because they had to remove all the structure and rebuild.
Right.
But nobody was injured, nobody died. But they lost money in terms of the materials that they
Yeah.
had to rebuild.
Yeah, that's crazy. I mean, the amount of weight that was probably on that pad as people were walking underneath it as those beams were continuing to deflect. And I mean, I would think that that would cause some concern, right? And
Yeah,
eventually they were able to identify it,
yeah,
which is thankfully, right? So that way because
yeah,
I'm curious what the weight was, given what they were supposed to have put in versus what was with the concrete pour and as they
well,
were continuing to build.
yeah. I think that's what got them thinking, right? I mean,
Yeah.
because we call it a ponding load.
Okay.
So typically, when you pour a structure, even when you have the right size beams and girders,
Uh-huh.
it's going to still deflect. And
Yeah.
so
Yep.
you have to bring the concrete to a flat level. And so you do add some additional concrete.
Hmm.
And they made room for that, but it was just that it was so much. And
Yeah.
thankfully it stopped, right? Because if
Yeah.
they had continued pouring concrete to try to flatten the floor, then that structure would have collapsed.
Oh,
You
yeah.
know, yeah. And so those are the types of there are many near misses.
Yeah.
In fact, there's an organization in the U.S. now, I believe it's called Cross U.S., where where they are encouraging. It started from the U.K. They're encouraging people to report anonymously uh, collapses, or failures,
Uh-huh.
or near misses, right?
Yep.
And report it anonymously so that people can learn from that.
Yeah.
And there are some reports there that I've seen where people are reporting it anonymously so that others can learn and say, hey, next time, if you have, software, make sure you check the default settings, right?
Right.
I mean, that's what I learned from it. And that's what
Yeah.
the person that did the original design of this building
Right.
learned from it. Make sure you check the default. What does the default of the software say? And what does it
Yeah.
require?
Well, like you and I just talked before we started this episode, technology is great when it works, and it
Yeah.
worked, right? However, there are a lot of inputs, and as we start to, go into the field of AI, and we start seeing some of these things, I wonder if we'll start seeing maybe, and I don't know if this is something that you guys at Drexel or academia they start to take a look at, is maybe some type of AI review of some of these structural calculations to see if there's something out there that might cause somebody to pause a little bit before they move forward and maybe take a look at some of those inputs.
Yeah, I mean, right now we do have, review systems in place,
Okay.
right? I mean, if you design something or a structure, a senior engineer can take a look at it and
Hmm.
just without doing even any calculations, just look at the numbers and say, based on what other projects that I've done in the past, these beams look too small. Go
Yeah.
double check it. So we do have those types of reviews or peer reviews
Right.
within companies right now. And maybe AI will make it better, but
Yeah.
I'm still a believer in, an engineer, a,
Yeah.
a trained engineer taking a look
Yep.
at the building because at the end of the day, if the AI makes a mistake, the AI is not going to be jailed.
Right. Yeah.
You know?
They're going to be looking at you or I, if something
Exactly,
happens. Yep.
exactly. So I think you still need a live engineer to go in there,
Yeah.
do quality control, look at the drawings. I mean, that's some of the things that I believe was missing in the case of Surfside. I mean,
Yeah.
some of the mistakes that we found were like, was like, this should have been found by someone.
Well, yeah, and I mean, in watching, some of the news reports, reading some of the news reports, watching some of the videos associated with it, and and seeing some of the columns themselves, and anywhere from the columns to the details that were
Yeah,
submitted for review, there was just kind of a totality of a lot of things. Like we talked about what you said about the Kansas City, and that one failure and that one point that could have been an easy identifiable detail.
yeah,
But a lot of the things from Surfside, could have definitely been, some of that stuff should have been caught and maybe easily mitigated
yeah.
to help reduce that.
That's correct. I mean, cover, for example,
Yeah,
and waterproofing, sloping of the pool deck slab.
yeah.
I mean, things like that. There were just a ton of things. There were a number of things that were just not done right.
Yeah. Yeah, and that's why I think, like you just mentioned earlier, making sure to have like an engineer there to be able to review things, and that's why
Yeah,
I always tell people having code officials and engineers work together. That's when really things work well. I mean, for myself, and I'm sure my building official folks and partners and friends, we want the building to go just as much as the
yeah,
engineer and the developer and designer, but also too. And I'm sure, as you can probably relate to this, we want to make sure that it's safe. We want to make sure that nobody's going to get injured. We want to make sure there's no collapse. For me, there's not going to be a fire. If there is some type of
yeah,
emergency, people can get out, all those types of things. And so
yeah.
it's all good. I think, it's one of those things when we can all work together in a partnership. I think
That's
that
correct.
a lot of what we need to look at. Now you mentioned the forensic class that
Yeah.
and how long has that forensic class been offered at Drexel?
Since 2015.
Okay, so quite a while.
Yeah, quite a while. Yes, yes.
So now, when you started that class, what's the typical analytical approach that you utilize when reviewing these types of structural collapses? And I know for me as a fire investigator, I utilize, we utilize NFPA 921. It has and it recommends the scientific method. So we collect our data, we test our hypothesis, and then we select that final hypothesis. Now, granted, I simplified the whole process in
Yeah.
three bullet points, but what is that failure or kind of that analysis approach that you go through when looking at these structural failures?
We basically use the scientific method
Okay.
as well. I tell, the students, I go, when there's a failure, first of all, you approach it with an open mind. I mean,
Hmm.
you want to do, really at this point, real divergent thinking,
Yeah.
what are the possible failure modes or mechanisms
Yep.
that could be attributed to this structure. Now, for some structures, we know what the predominant failure mode is, right? For example, if I see a slab that is sitting directly on a column,
Hmm.
I'm thinking punch and shear.
Yep.
That's what I'm thinking as a structural engineer. Okay, I need to check punch and shear, but I also need to check, if it collapsed. I mean, did the car, if it's a parking garage, the car hit the column.
Right.
And was there an explosion?
Hmm.
I mean, or the column itself over time, uh, has the rebar within the column, or if it's a steel column, has the steel column corroded,
Right.
because maybe there was seawater infiltration. So I need to check all the various possible failure modes,
Okay.
you know, and then again, without speculating, uh, based on the evidence, and analysis, then you can rule out or rule in, the hypothesis, and then
Hmm.
you might come up with maybe two,
Right.
hypotheses that are kind of close, and you're not
Yep.
able to pick which one,
Yep.
and that's fine because sometimes. You are not able to identify exactly what's the trigger. Sometimes
Right.
you're able to do it.
Yep.
And in the case of Surfside, for example, when I did my analysis, which I presented in so many venues already,
Hmm.
you know, I looked at the pool deck. I knew that I was suspect. Uh, then I looked at where the pool deck itself connects to the tower because there's a
Right.
step beam there. Those
Hmm.
beams too were suspect. So my sense was that the pool deck went first, but those beams too were suspect, and they could have gone as well because the video from across the street showed that collapse having
Yep.
taken place.
Yep.
So those beams might have gone first before the pool deck. But I mean, I was not dogmatic about it. I just basically said the pool deck is bad.
Right.
Those beams themselves are bad as well.
Yeah.
And either of them or both of them go, the structure goes.
Right.
And so you have all these hypotheses. And in fact, I have so many hypotheses listed. I mean, I ordered them when I presented
Yep.
my keynote at the Structural Engineers Association of California. And also I presented to NIST
Hmm.
when they had my keynote, they heard about my keynote. They asked me to present to them. So I had all these hypotheses listed, starting
Right.
from one that I believe is,
Yep.
top-notch ones.
Yep.
And the ones that I couldn't determine, but their hypotheses, I couldn't determine whether there was an explosion because I don't have the debris. I don't have,
Right.
those are limitations that I
Yep.
listed in my report, and presented that to them. And then analyze based on the evidence and based on, you know, what we know, the material strengths,
Yep.
which again I had to assume as an observer from afar, I had
Right.
to assume based on the design strength. NIST, for example, can do a test on a
Yep.
specimen to find out what the design strength was. So that's what I teach my students. And then,
Yeah.
and we, other things that we consider as well for a structure is that what about the original design? Was this
Hmm.
structure originally designed? Was it okay?
Right.
What about, were there design errors? Were there construction errors? What about maintenance? Was there a lack of maintenance? Deferred maintenance that could have, caused deterioration and lack of strength or reduction in
Hmm.
strength of the structure. And then, like I said, you ask it, also were there extreme loading, like
Yeah.
explosions or did a car ram into a column? So all of that you consider, and then you do the analysis, and if you like NIST, if you were NIST, you will also do some experiments,
Yeah.
maybe break some concrete to find out what the strengths are, and do some testing, and then write your report and come to a conclusion.
Yeah. So it sounds like a very similar approach to what I take as a fire investigator in the sense that, definitely you develop those hypotheses and then you try to, prioritize and you try to test them in
Yeah.
any manner that you have. I mean, we do a lot of test burns just to see how fuels
Mhm.
react.
Yeah.
And it's, to me, it's, like you were mentioning videos and things like that. It's the totality of evidence, right? As we do fire investigations, we always talk about, we're getting witness statements, we're analyzing patterns, we're
Yes.
looking at the fuels, we're looking at, the science behind it, and then that helps kind of help us develop it. Wanting to go in with or needing to go in with an open mind because we don't
Yes.
want to have that bias ahead of time, right? Like,
Yeah.
well, hey, I just had one of these the other day, and this is what happened, and
Yes.
and you'd be foolish to not have an open mind and not rule out some of these other things that could be easily ruled out,
Yeah.
or ruled in as
Yeah.
well.
Exactly. Exactly. Yes. Yes.
But now you mentioned as part of that, you look at the original design, and a lot
Yes.
of times original design is reviewed by code officials, but also too the annual inspections and those types of things that we go through every year on many facilities, not all facilities. We try to get into as many as we
Yeah.
can, and so there could be some design and construction errors. But what's your view on the importance of kind of code enforcement, plan review, and those types of things? We talked earlier about it being kind of a collaborative effort, but what's
Yeah.
your view in regards to that?
So my sense is that when a building has been designed, or just before it's built, obviously it goes for plan review.
Uh-huh.
Uh, there are some jurisdictions that I feel um, maybe too
Yeah.
small to handle some projects. Um, I haven't, the question I had with Surfside was, why didn't someone either at the plan review stage or, catch some of the glaring errors?
Yeah.
For example, I mean, this is like ocean front,
Mm-hmm.
and the cover to the concrete rebar is 3/4 of an inch. That shouldn't be. I mean, that should be like a red flag right there.
Yeah.
That I mean, that's way too small. I mean, that's what you'll use in Philadelphia. I mean, like, so now we are in a coastal zone and we're using 3/4 of an inch. That should be flagged. So there were so errors like that. So I believe that plan review is really crucial. I mean, it is
Mm-hmm.
crucial. Uh, but not every jurisdiction has the capacity,
Ability. Yeah.
the ability to review. I mean, a building like Surfside, 12-story building
So
in a
it's
town like Surfside, I don't know if they had a structural engineer on duty,
hmm
as an
Yeah.
employee.
Yep.
And so in that case, I believe ICC also has code reviews that they do.
They do. Yep.
Yeah, I mean, this should be farmed out. I mean, this should be contracted out either to,
Yep.
folks like ICC or to a private structural engineering firm to
Yep.
be a third party to come out and do these third party reviews. I
Yeah.
believe if when that is done, that will help prevent some of these issues, that we found in Southside.
Yeah, and that's one of those things that, as a code official, we do, definitely use third parties to help assist us. And I am not an engineer, and nor will I claim to be, but I do have some level of experience, but I know what my limitations are. And the code identifies that in the sense that it talks about that, seek technical opinions
Yeah.
and research reports and those types of things. When you receive those types of designs, because I would say building and structures are not getting any simpler in the sense that you're getting a lot more automation, right? And we
Mhm.
want to try to be able to build these buildings to be resilient, not only
Yeah.
just the structural collapse, but also we talk about, Surfside, the saltwater intrusion and
Yeah.
those types of things, Mother Nature and trying to make sure that, it's going to be here for, the next 40, 50,
Yeah.
60 years. So
Yeah.
what do we do? But identifying those limitations and finding people that can help assist you. And I
Yeah.
think that like you mentioned, some jurisdictions that may not have structural engineers on
Yeah.
board, maybe seek and find maybe third parties that can help assist. I know that we have, and it typically is one of those things that, as you mentioned, ICC does have.
Yeah.
Not to put a plug in for it, but they
Yeah.
do have some plan review
Yeah.
capabilities. So,
Yes.
but now, one of the things with Surfside, they had the 40-year certification, right?
Yeah.
And we talk about the 40-year certification, and now and I know you've talked about maybe hopefully reducing that recertification period maybe to 10 to 15 years.
Yeah.
Can you explain, really, how often should these recertification periods be for some of these larger structures, and verify that the structural integrity is still intact?
So when I look at a building, I look at, okay, what is the design life? What do we typically, estimate the design life to be?
Uh-huh.
It's about 50 years.
Okay.
Some bridges, maybe 75 years. So, I look at the buildings, that's the design life, 50 years old. First off, I don't want the first time that the building goes to see its doctor is when it's 40 years old.
Yeah. Yeah, that makes sense, right? You don't want to, we've only almost hit the whole lifespan, right? And now
Yeah,
we're gonna like
yeah,
I like the idea that
yeah,
the first checkup is not until it's almost like in its elderly stage, so to
yeah,
speak.
exactly. That's
Yeah.
80% of his design life. And so, and then I compare it to things like parking garages.
Hmm.
In New York State, they have parking garages inspected every 3 years.
Okay.
In New York City, they have it inspected, I believe, every 6 years.
Okay.
So I look at it again, and then bridges typically are inspected every 2 years or less. Again, just because they're exposed to the elements. So I look at buildings in coastal regions,
Hmm.
with their exposure, especially when you have a building like, Surfside with a pool
Right.
deck, and, the water table is high. And so
Hmm.
you might have infiltration and all of that. So I look at that and I say, well, I mean, just looking at it, comparing it to these other structures that are exposed, I think the 10 to 15 years makes sense as
Hmm.
the first time that the building is going to see its doctor,
Right.
right?
Yep.
I'm just looking at it again from a cost point, trying to, balance, cost versus safety.
Right.
It just makes sense to me that, maximum 15 years. And in fact, you should be inspecting the building more frequent than that.
Yeah.
More frequent than that. But I'm talking about the 15 years where you do like a milestone real.
Like you
Um,
bring a structural engineer in to take a look at it and looking at the structure itself, the integrity of that building.
exactly,
Yeah.
exactly. Because I think you will prevent a lot of, a lot of failures
Hmm.
in the future if you do that. I mean, you think about Surfside, and also you reduce the cost, you
Yeah.
minimize the cost.
Yeah.
Surfside started out, okay, they didn't do anything, and when they were trying to start doing something in 2018, it was going to cost them 9 million. Nothing was done.
Yeah.
2021, it was now 15 million. I mean, the cost keeps going up.
Right.
And now, what did they end up with? A collapse, and 98 people died. So I believe that the sooner we do it, the better. I mean, if you don't find anything, if the structure is fine,
Great. Yeah. Yeah.
I
Yeah.
mean, it's a win-win, I think. But
Yeah.
when you wait till too long, then it's going to cost you way too much to fix that structure. In fact, there's a rule of deferred maintenance that if it costs you $100 today and you don't fix that uh, particular component
Uh-huh.
on the next level of failure, that the cost is probably going to be squared.
Oh, okay.
So
Yeah.
it's called the Giveland rule. I mean, you don't want that. The cost is going to be
No.
squared. And
Yeah.
when they talk about cost, they're talking about not just the cost of fixing the component, but maybe the cost of if you have a collapse, the liability that you're going to have
Yeah.
and all of that.
Absolutely. Well, and like you mentioned, the financial aspects of it, and it's one of those things that as code officials, I've always heard the term making sure to try to be as reasonable as we can,
Yes.
and we try to do the best that we can, but obviously addressing the financial constraints in building maintenance is it is a big issue, and like
Yeah.
you said, if we continue to defer it, like I tell my wife, I said, things around the house, we better fix it now because it's going to be a
Yeah.
lot more expensive if we don't do it later.
Yeah.
And and it typically truly is,
Yes.
unfortunately.
Yeah.
but
Exactly.
but it's one of those things that as code officials, yeah, we do have those things happen. Now you hit on one of those things, checking that building more frequently. Is there something as I would imagine that there's going to be some property management folks that listen to our conversation. Are there things that property management individuals that are in that role can go out and things that they should be looking for, problem areas that they should, I mean, we talked about columns, making sure that the columns are not deteriorating, but are there other things that they should look at? I mean, I think about seeing cracks in walls and things
Yeah.
like that. But when do we find it to be a hazard, right? And when should we report it, and those types of things? So what can folks like that do as they do maybe an owner's inspection or a property maintenance inspection?
Yeah, I mean, I've always struggled with a
Hmm.
non-structural engineer doing an inspection because, if they see a crack, it might be a benign crack. It might just be
Yeah.
a shrinkage crack, right?
Yep.
But that shrinkage crack, uh, you know, uh, could be the source of salt water infiltrating the structure and then corroding the rebar and then leads to something worse.
Hmm.
So I believe that the inspection should be done by a registered design professional, whether it's the periodic inspection or whether it's
Hmm.
a milestone inspection, who can determine whether a crack, for example, if it's a shear crack, an angular crack in a beam, that's something that will raise an eyebrow.
Yeah.
If it's if it's just a vertical crack at the midspan of a beam, that's a flexural crack. I might be worried about it, but I could watch it. But if I start seeing diagonal crack at the end of the beam, it's a shear crack, and I'm worried about it because when shear
Hmm.
failure happens, it happens suddenly. It doesn't give you much warning than what a flexural failure will give you. So
Right.
I'm a believer that the inspection, whether it's periodic
Hmm.
or the milestone inspection, should be done by a structural engineer or a licensed design professional. I think you can bring somebody in. I mean, for just the periodic inspection, visual inspection, they go out and just make sure that you don't have corroded steel.
Right.
I mean, they can check that.
Yeah.
Make sure connections that you don't have hidden defects. That's the other thing,
Yeah.
right? If you
Yep.
have hidden defects that you don't know about, that could lead to collapse.
Yeah. Now we talk about financial constraints, and deferred maintenance, and I don't think, and the things that I've read and the things that I've watched in regards to Surfside, there was never anything that said that it was an imminent collapse. They said, hey, these are $9 million. It's gonna, and I think it increased to 16 as they were looking at trying to do the maintenance of, or take care of the deficiencies identified in the engineer's report. But we talk about imminent collapse and we talk about trying to be reasonable, but and I don't want to say like, and yeah, I kind of feel like I'm painting you into a corner. Like, what are those things that have to be done, as we start to take a look at these things? Because since nobody said that, hey, if you don't do these things within 30 days, you're gonna see a structural collapse. But what are some maybe red flags that you would recommend? Because like myself, I may not get this report. It might go to the building department. But
Yeah.
what are some of those red flags that we should look for as we take a look at these reports?
Yeah, I think that with Surfside, they should have red flagged that
Hmm.
that this was in imminent danger of collapse. I mean, all they needed to do was just check the pool deck,
Hmm.
for punch and shear, and then look at the fact that there was deterioration going on as a result of the pool deck, the ponding of salt water on the pool deck, and so at the very least, that pool deck should have been shot up at the very least. So when they notice, for example, that the planters in early June, sometime in June, uh, the planters were just cracking. The planters are not structure, but they are
Yeah.
supported by the structure. So the planters were cracking. So uh, that should have been, again, another red flag.
Yeah.
Why are these planters cracking? Go downstairs, check the columns that are supporting those planters, and find out what's going on, because sometimes you can't see the cracks because the cracks may be above the slab, but the
Yep.
slab itself is covered up with pavers.
Mm.
So you may not see that. So
Right.
that is a warning sign. At least they should have gone down and looked and see whether, there was deflection taking place, whether there was and there was deterioration. They noted that in one of the columns where water was just pouring down. In fact, I think the Miami Herald called that column, said somebody called that column a waterfall. They should have
Oh,
at least shot up
yeah.
that, parking garage,
Yeah.
and then decide whether to evacuate the building. So I will say that in terms of warning signs, the numbers will show it. That is,
Hmm.
you do the analysis, you check for punching shear capacity, and that will give you, an idea that something is wrong. I mean, when I checked it, there were things that I found, columns that were kind of like on the edge, really on the
Hmm.
edge, even within the tower, columns
Yeah.
that were on the edge. So things like that. Um, and then a pull deck slab for which the punching was inadequate. Punching shear capacity was
Right.
inadequate. And then I already spoke about the stepped beams
Yep.
that connect the pool deck to the tower structure. So the numbers should show where the concerns are, and if they had checked those. To this date, I don't believe that I've seen any calculations where they actually checked the punch and shear capacity of the pool deck.
Mm. So they never actually did that final analysis to be able to see if that, if there was a failure or not necessarily. Maybe the calculations themselves, they didn't check those.
I didn't see any calculations for anything that happened between that
Mhm.
2018 or even from the very beginning up
Yeah.
to 2021 when people started to take a look at the structure as a whole.
Yeah.
There were no pool deck calculations for shear, punching shear that I have seen.
Wow. And it sounds like it further deteriorated, as time was going on. You mentioned the planners; they started to, crack, and that was in early June as those started to crack.
I'm in June, yeah, before the
Yeah.
collapse, yes.
Yeah.
And they had called the engineer in, and they took those pictures of the planters with the cracks. That again was, I believe the structure crying out through
Yeah.
the planters that, hey, show me, or evacuate this building. I mean, if they had done that at that time and then stepped back and take an overall look at the building,
Hmm.
perhaps the 98 people will have still been here with us.
Yeah. As we talk about, the idea, identifying those issues and being able to make those corrective actions, and how much is it going to take? We talk about, like, hey, if it's 9 million, it's 16 million, and identifying, we talked a little bit about the red flags, but one of the things, kind of shifting directions a little bit,
Yeah,
modern structural systems have definitely improved. I would say code enforcement and design provisions have improved significantly,
yeah,
over the decades and the many years that codes and standards have been put in place. And so, as we take a look at that, that's one of the great things. And hopefully over time, that will help reduce or make the impact minimal towards, making some of these changes, right? Like
yeah,
you said, shoring up those columns. Like, how much would it be to be able to shore up a column, and being able to pick those red flags and be able to do those things. And like I said earlier, being reasonable and trying to find, solutions, because they always push back on the code official when we
yeah,
say you've got to do these things. And then they're like, well, we're trying to do the best we can. We got to, as we talk about deferred maintenance, how do you balance that with making sure that they continue to do that? But what are some modern building systems or modern things that we've learned from that we could potentially implement to help maybe offset some of these, potential structural failures that we're starting to see more of?
yeah. So back to Surfside, there were some things that were not used in Surfside that are now in the code that
Mm.
were not used, not because the engineers at the time were negligent on that front. Uh, it was just that was not in the code. We call it integrity reinforcing.
Mm-hmm.
Integrity reinforcement means you have rebars that goes along the column lines in both directions.
Okay.
And so the idea of that is that when you have punch and shear failure, when the slab drops, when you have rebar, that rebar is going to keep the slab hanging.
Yeah.
They didn't have that because the building was built in 1981. Integrity reinforcement came into the ACI code, the American Concrete Institute code, in 1989.
Okay.
So we have that now that helps mitigate
Mm-hmm.
punch and shear failure, so you don't have the slab pancaking on top of one another. Um, some modern structural systems that we use to increase strength, for example, of structures is they're called fiber reinforced plastics.
Mm.
So we can wrap that around columns that have been weakened, and pour concrete around it,
Okay.
to sort of strengthen the concrete columns, and also to widen the concrete columns, because punch and shear has to do with the size of the
Mm.
column. If you make the column bigger, you increase the punch and shear strength of the slab.
Okay.
So that has been done, over the years. And in fact, I read a paper recently where there were some columns, again in Florida, where the concrete strength was like 1,500 psi,
Okay.
very low compared to maybe 4,000 that may have been the original design strength. They don't state what the original design strength is, but
Mm-hmm.
they stated that the excuse me,
No worries.
they stated that the current design strength was 1,500 psi.
Okay.
They had to wrap these FRP, fiber reinforced plastics around the column to increase its strength.
Mm-hmm.
So, those are the types of modern materials that we have available that we can use, not only for columns, but for beams and girders as well.
So it's one of those things that, it sounds like it's more of a lighter weight material that we can definitely incorporate into, retroactively incorporate
Yes.
into some of these buildings, because I don't think you're going to break that column down and now add a bunch of rebar,
No,
trying to address that challenge, right?
that's correct. That's
Yeah.
correct. We're retrofitting the column. We're trying to, make the column stronger, or at least maybe up to its original strength.
Yeah.
But no, we're not going to break it down. Otherwise, I mean, that's demolishing the whole structure as well, and just bringing the whole thing down and rebuilding.
Yeah, I mean, it's good to see that, and I think over time, we'll start to see some more, modern materials that will make it a little bit, increase the flexibility to be able to build off of and be able to address some of these limitations that we've seen in these structures over time. I definitely see it in fire protection systems all the time.
Yeah.
Just different things that they can do. So you mentioned just a minute ago about reading papers, and I'm sure, in academia, you try to stay up to date as much as you can. But, as I look at it, and you mentioned giving the keynote address for the California Structural Engineers Group, then also doing a presentation at NIST. But, what are, as I look back and think about the kind of the who listens to this podcast,
Yes.
our code officials and maybe engineers, and where can they stay more up to date on like the work that you're doing and the different things that we talk about? We've talked about today about structural failure analysis and retroactive and modern building materials.
Yeah, I think the best resource that I use, from my point of view, is Structure Magazine.
Okay.
Structure Magazine is at structuremag.org, and they're practical, but they also talk about theory.
Mm-hmm.
And so, I use that a lot. And they talk about structures that have been built, structures that are having issues, how they were fixed, things like that. So Structure Magazine is one, but the ASE, American Society of Civil Engineers, also has a library of webinars
Oh,
that folks can listen to. And the American Concrete Institute Structural Journal is a little bit more on the theoretical
technical.
side,
Okay.
but it's also quite useful to sort of get an idea of what's going on.
Uh-huh.
And you have the American Institute for Steel Construction. They have their engineering journal. They're quite practical as well and theoretical at the same time, but they come up with relevant papers from time to time. I think that's quarterly, the AISE engineering journal. And then you have Woodworks,
Uh-huh.
Wood, Woodworks website.
Yep.
It's a very useful website for wood, buildings. So
Yeah.
those are the ones that I use.
And we talked to in the previous episode, we talked to Ray Obraki with the American Wood Council on construction fire safety, and so yeah, I mean it's one of those things that if you get involved in code development, a lot of times you start to identify those folks and those. Maybe those other organizations that are definitely deeply involved in code development, and where do they get their, I remember when I went to my first code hearing, it was on the residential code, and there was probably a 2-hour discussion just on deck rails alone.
Hmm.
And I did not necessarily ever think that deck rails would be that hot of a topic, but it is. Uh,
It is. It is.
yeah.
Yeah.
And so it gives you definitely a different perspective on
Yes. Yes.
and I didn't know there was a Deck Rail Association of America, but there is. And so it's just one of those things, you just kind of see those
Yeah.
things and you realize that there is a lot that we don't know.
Yes. Yes.
And so just be able to stay up to date is vitally important.
It is.
And that's, to be honest with you, that's why I like these podcasts, because I learn a lot. I always learn a lot from talking to different people that are definitely much smarter than I am. So,
Yeah. Yeah. I tell my students, I mean, when I tell my students that I still learn,
yeah,
that, I don't know it all yet, that, I'm learning every day.
yeah,
And yeah, they're going to continue learning. And I tell them we call it lifelong learning,
yeah.
that's why it's lifelong, So yes, we have to continue learning.
Yeah, when I was kind of naive when I first began my career. I always thought that I was going to hit that point where I was just going to be so knowledgeable that I was going to know everything. And I am almost 20 years or 25 years into this profession, and I learn something new almost every day.
Yes.
It's just amazing, the different things and the technology and all
Yeah.
of that has evolved over the course of time. You know, before we end this episode, let's
Yeah.
look to the future a little bit. And as we talk about, one of the things that has been a big topic of conversation is climate change and how that impacts the kind of the structural integrity, as we move forward. But what are some challenges and trends and that, especially in building safety that, our listeners should be aware of?
So, right now we do inspections, for example, visually, right? We go to
Yep.
site and we do inspections. If you look at cars and airplanes, they are all instrumented with sensors.
Yeah.
And so there's been that thrust in that direction as far as structures are concerned, that why can't we have sensors
Yeah.
in buildings?
Yep.
I mean, of course, a building is a large a large structure. I mean, like
Uh-huh.
a behemoth, right? I mean, like,
Right.
where do you put the sensors and so you need a structural engineer to tell where strategically those sensors will be placed.
Right.
But there's been a ton of work going on, going on right now in structural health monitoring, where they're
Okay.
using embedded sensors or sensors that are attached to a structure and trying to figure out if we can have that sensor calibrated in such a way that it will give us a warning when a certain threshold,
Hmm.
let's say, of displacement or displacement in a structure or deflection of a structure, if it's exceeded, it sends a warning. for example, take Surfside. If for example, there were sensors that when a beam goes down,
Right.
or before the beam goes down, even just the cracking that's taking place, there's an alarm that goes off. So
Yeah.
there's work in that area that is ongoing as we speak. So that's
Okay.
one area that I see, um, you know, is taking hold right now and will become even more predominant in the future. Another one that I've seen recently is drone assisted inspections.
Oh
So,
yeah.
depending on the height of the structure or
Hmm.
how dangerous it is, you can use drones to do the inspections rather than, a human being trying to climb on a scaffold or something like
Right.
that.
Yeah.
So that's another area that I've seen. And coming down the pike, um, before now, only Florida, Miami-Dade had the period, the recertification. But I
Hmm.
think that in the future, more and more jurisdictions
Yeah.
are going to have, periodic inspections and milestone inspections.
Yeah, you got to start doing you got to have those inspections to be able to at least identify where your failures are.
Yeah,
I'm fascinated by the aspect of, the sensors and the technology that could be coming, I would say in the not too distant future.
yeah,
Feels like technology is moving at such a rapid pace right now. It's just, crazy to see some of the things that we've seen, just in the last, 6 months to the last year. And as you were talking about some of those sensors, I think about like the development of different fire alarm components,
yeah.
and how do you incorporate that into the fire alarm so the fire alarm goes off if there's an immediate danger, all of those types of things, right? It's just I'm kind of interested to see how that all, and what ultimately ends up getting required in the code.
Exactly. And there are challenges. I mean,
Yeah,
where is the data stored?
yeah,
Where is the data stored? Who manages the data?
yep,
Uh, will you have a resident or a structural engineer that you will have on a retainer
right,
that's going to be reviewing this data? I mean, I'm talking about the owners now,
yep,
because the owners are not necessarily structural engineers. So where's the data stored? Who analyzes the data? And
right.
all of that, so there are still some challenges, but there are companies that are marketing these sensors as we speak,
Huh.
these types of sensors as we speak. So it's here, it's just
Yeah.
the logistics of getting into the building. And like you said, what will be required?
Yeah.
What will the code require in the future? Will the code require that you're building a new building, you need to, have monitoring with
Right.
sensors, in certain
Yep.
areas?
Yeah, and like we talked about earlier, being reasonable. Obviously, there's always a cost impact, right? And that cost impact is one of those things that I see a lot of concerns when new things are brought into the code. As we talk about cost and making sure that we can make things continue to be affordable. And want to definitely, I mean, we could do a lot of different things and make a lot of different changes, but we want to continue to make things affordable. And how do we balance that? And it is a challenge. I've seen it a lot. So
Yeah, it is. I mean, with condos, for example,
yeah,
deferred maintenance. Why do they defer the maintenance? Well, because, I mean, frankly, who wants to pay
yeah,
if they can avoid it? But then the consequences of not paying the assessment or not assessing, down the road is very can be catastrophic. The condo associations, at least in the U.S., as far as I know, don't have a mandate to have reserve fund studies. And, I know that in Ontario, Canada, for example, they do reserve fund studies, I believe, every 3 years.
mm,
And so, they're on top of what it's going to cost to repair and replace. They talk about the useful life left,
uh-huh,
let's say for your roof, uh, for all the components of your structure, and you calculate all of that. And so that at the end, when that thing really breaks or comes to a time to replace it, you
Right.
have about 85 to 90% of the amount of money that you need
Yeah.
to fix it. Because if you have nothing at all, like Surfside, I mean, they had 700,000 or something like that, less than a million in their account, and they needed 9 million in 2018 and 20, 15 or so million in 2021. I mean,
Right.
there was no way they were going to do that. And so they
Yeah.
had to assess everyone,
Yeah.
and the assessment was huge.
I want to say, wasn't it $100,000 per? Yeah.
Yeah, it was
Yeah.
huge.
Yeah.
So how do people afford that and then still afford their mortgage and then still afford the HOA fees,
Yeah.
the fees that they pay every month?
Yeah. Yeah, and it's one of those things that we talk trying to find that balance, and that's a challenge. And
Yeah.
if we defer it for so long, and so kind of as we talked earlier, being able to reduce that cycle to make it more manageable
Yes.
is definitely going to be one of those things. And hopefully with some of these emerging trends, we'll be able to identify some of these red flags as we talked about them earlier, before they become, critical red flags,
Yeah.
and that lead to structural collapse. Well,
Yes.
Dr. Aguirre, I really appreciate you joining us for this episode of the podcast. I think it very informational. I think that there's a lot of people that are going to take away some different things, either code officials or structural engineers or anybody that's interested in the building safety profession. I'm sure you deal with that a lot at the university level, whether or not they're going to be, engineers or they're going to get involved in the public sector. We're always looking for people in the public sector. So, not to try to maybe help sway some of those folks that might be, your students, but we're always looking for good people to kind of like
Yes.
we're definitely a aging population, and we're having troubles filling some of those
Yes.
critical positions within what we do on this side of things. So,
Yes.
is there anything else that you want to share with our listeners before we wrap up the episode?
One other thing with condos is that they usually have an attorney, on the board or at least advising the board. I think they should have a registered design professional as well, maybe on a retainer
Mm,
advising the board because the board may have no experience at all to
yeah,
know, what should we look for in a structure and
right.
I think they should have, maybe a registered design, professional as a member of the board, maybe as a consultant
Yeah.
on the board. That's one of the recommendations that I will proffer.
Yeah, so have find those subject matter experts
Yes,
that can definitely help you through this
yes,
process
yes,
as much as you possibly can.
yes,
And that recertification period, if we can find ways that, we don't, as we talked about earlier, you don't go to 80% of the lifespan of the building before you
yeah,
actually have that checkup. And that might be one of the things, as we talked about just a little bit ago, that we see that to, move forward in the sense that, that aspect of having, being able to identify those problems early on,
mm,
are definitely going to help reduce that cost, and hopefully that will help, mitigate any future disasters should we see them. So,
yeah.
where can people find more out about you and your work, especially at Drexel University?
Yeah, they go to drexel.edu and they go to my Department of Civil, Architectural, and Environmental Engineering. They will find me there.
All right. And I've been there. There's a wealth of different things that you've been part of.
Yeah,
Like I talked about earlier, the Smithsonian, the video, or the episode that was like
yeah,
45 minutes just on
yeah,
Surfside alone. Highly recommend it. And some different things and different videos that are out there. It's one of those things that you will learn a lot.
yes,
And I've definitely have learned a lot myself throughout the course of one preparation, but also then talking to you. So,
yes. Well done.
well, again, I really appreciate it. Is there anything else before we wrap up the episode that you want to share?
That would be it. It's been a pleasure joining you and on this episode.
Yeah, fantastic. Well, hopefully everybody learned a lot, and hopefully we'll have another episode soon. Thanks,
Yeah.
guys.
Okay. Bye bye.